Hi class, this is going to be the solutions to the Interpreting Kinematic Graphs worksheet. I'm probably going to talk a little fast here just to make sure I can finish in 15 minutes. Feel free to put this in like 0.75 speed or pause it as you go along. Alright, first question basically says there's a graph. We want to know the interpretation of the graph. It's a velocity versus time graph. It's in the top half of the graph. I know it doesn't show the bottom part down here, but it's the positive part of the graph, and the line is going towards the x-axis, which is 0, which means A. The velocity and the speed are decreasing. Number 2 says, how would you find the displacement of the object shown in the graph from 0 to 2 seconds? I see that it is a velocity graph. To find the displacement or distance, I'm going to need to shade. Finding the area between the line and the x-axis, which happens to be B. Number 3, what is the acceleration during the first 2 seconds? You have to know that on a velocity versus time graph, the acceleration is the slope. So if you find the slope of the graph above, the answer should be B, 2.5 meters per second squared. Number 4 says, how far does the object move in the first 3 seconds of motion? Again, this is a velocity versus time graph. When I see that, I immediately think shading. So in the first 3 seconds, I see that triangle right there. So I do 1/2 base times height, 1/2 times 3 times 4, and that should get me the answer D, 6 meters. Now, for number 5, I want to know how far it goes in the first 6 seconds. Well, in the first 6 seconds, well, now I've got to have a bigger triangle, like this whole triangle right there. So that's 1/2 base times height, so that's 1/2 times 4 times 5, plus I've got this rectangle that I'm drawing right now, and that's going to be base times height because it's a rectangle. So that's going to be a base of 2 and a height of 5, and when you add that all up, you should get 20 meters. So area of a velocity versus time graph is the distance or displacement. Number 6, which of the following is true according to the position versus time graph below? Alright, so it's a position versus time graph. It's asking about instantaneous velocity. Velocity that's instantaneous means the speed right now, so they're talking about t equals 5 seconds. So who's faster in that region? Well, in that region I can see A's line has a greater slope, B's line has a smaller slope, I guess I should say, which means that object A is going to have a greater instantaneous velocity. And I just kind of explained it right there because the slope at t equals 5 is greater. All right. Question number 8 says, what's the instantaneous velocity at t equals 2 seconds off the graph? Well, what do you know? It's a velocity graph. This graph tells us the velocity. So at t equals 2 seconds, I go up, I go over, and it tells me that that is going 5 meters per second for that one instant. Number 9 is 3 graphs. I want to know which ones have an acceleration of 2. Well, graph A is a position graph, and that's a straight line. So that's constant. So that can't be A. If I look at graph B, it's a velocity graph. It's got a slope of 2, and the slope of a velocity versus time graph is the acceleration, so definitely B. And then C is actually still a velocity graph. It's still a velocity graph. It's got a line that's horizontal, which means it's staying at 2 meters per second. So it's not increasing its speed, it's staying at a constant speed of 2, which means it's not C. And the answer is B only. Number 10, instantaneous velocity at t equals, I think I had you guys change that to 4 seconds, so the problem would work out okay. Instantaneous velocity means the speed right now. I am looking at a position versus time graph, and I have to get the slope at t equals 4 seconds. So the slope of a position versus time graph tells me the velocity. So if I go up and I go across, that's 5, but that's at 5 meters. So that just means I have to find the slope. So any 2 points along this line, like right there and like right there, I know it's a little bit off, or any 2 points along that line going down to the right will get me the answer. And if you do that correctly, because it's going down and to the right, it should be -1 meter per second. Number 11 is a pretty easy graph. It's a position versus time graph. You should see that one is going in the positive direction, one is going in the negative direction. You can see that the slopes are different. The truck slope is greater. You can see it goes from about 18 down to 0, while the car goes from 0 meters to about 11 or possibly 12 meters, I guess I should say right there. So they're going in opposite directions because the slopes are different, but the truck has a greater speed because of the slope, which makes answer choice D correct for that one. Number 12 is a position versus time graph, and the question is asking us for how fast the car is moving. So the velocity or the speed off a position versus time graph is just the slope. So this is a pretty easy one. You just pick, I don't know, maybe the first point at 0, 0, and then during the first 8 seconds. So I'll pick the first point and the last point. It's a straight line. Any 2 points along that line should give us the slope, which is the speed. So it would be 12 over 8 is the slope, which should get us B, 1.5 meters per second. 13, number 13 says, which of the following graphs shows a car that's accelerating for 10 seconds and then continues on, and I meant to say at constant speed for 10 more seconds. All right, so let's see, which ones accelerate? Well, not that one. This one slows down, that one slows down, so it's A or E, but A, but stopped. Horizontal line has a slope of 0. That means the speed is 0. This is the speeding up part. And then this last part I just circled, that's constant speed. So the answer is definitely E. Number 14, I want to know the instantaneous velocity at t equals 3 seconds. All right, well, it's a position graph. Right away, I should go, all right, I want the speed off a position graph. That is slope. So you have to pick 2 points along the lines, right there along that line that 3 seconds is on, so anywhere along there. So I bet you most people would go pick the first point, pick the last point, and go down 10 over 1, 2, 3. So down 10 over 3 is going to get you -3 meters per second. Number 15, it's a positive acceleration. How do you get a positive acceleration? The 4 in this case doesn't matter. We just want to know, how do you get a positive acceleration? Well, you got to have a positive slope in the velocity versus time graph. So to get that, you either have to have a velocity versus time graph that is either doing this, that's a positive slope, or that, which is a positive slope. In which case, those two options are in the positive direction and speeding up, or in the negative direction and slowing down towards 0, which means the answer choices are A and D. Number 16 is a really tough problem here. What's going on here is an object is moving in a straight line at time equals 0, and we want to know along the graph, when does the object get back to its original position? I think most people are going to go, oh, well, it goes backwards then forwards, but this is a velocity versus time graph, which means that the object is going and speeding up in the negative direction and then slowing down in the negative direction. So it's going in the negative direction the whole time. In fact, this is the distance, the area that it goes. So I said to myself, when does it have the same amount of area when it goes forward, which is the top half of the graph? And I was like, I don't know, like right around there it seems to have, you know, the same amount of area. You know, if I went to 2 meters right here and I did this whole triangle right there, I would see that it is a greater area going forward in the positive than it is in the negative. So that would lead me to conclude that somewhere in this region, like right around in here, that's when those two triangles have the same distance, the same shading. So that's when the object has crossed back to where it started. So that's somewhere in between 1 and 2 seconds. Number 17, I got to create a velocity versus time graph off a position versus time graph. So I got to find the slope. That's what I got to do. So I got to get the slope, I got to get the slope, and I got to get the slope. All right, and when you find those slopes, just because I'm trying to save time here, those slopes are 1.5. So I'd go to here, 1.5 for the first, and it stops here actually at 8 seconds right there. And then it's got a slope from 10 to 18. So from 10 to 18, it's got a slope of 0. And then actually here, from 20 to 25, if you look, it has a slope of -1.5. Actually, let me make sure that's correct here. So it goes down, let's see, 2, 4, 6, 8, 10, 12 over 2, 4, 5. So it goes down 12 over 5. So that gets me a slope. Let me check that on my calculator really quickly here. Down about 2.4. So I got to go to about 2.4, about 2.5-ish. It's going to be tough to tell the difference. So right about there. Now the tough part of this problem is that there's these little curves there, and they actually don't want you to ignore those. That's actually the time when the object is slowing down to a speed of 0 and then speeding back up in the opposite direction. So that's where they actually want you to connect those lines right there. All right, moving along. I think I actually made a mistake in my answer key. I'll have to go ahead and fix that for the slope of that very last part. Calculate the acceleration of the elevator from 0 to 8 seconds. Well, that from 0 to 8 seconds, it's got a constant speed, so the acceleration is equal to 0. And then the acceleration from 8 to 10 seconds. Well, let's see. We could do this formula, Vf, or just V, equals Vo plus A times t. And we know that the final velocity is 0. We know the initial velocity at t equals 8 to be 1.5. We don't know the acceleration, and the time that it takes there looks to be about 2 seconds. So if you do the math on that, we should get an acceleration of negative 0.75 meters per second squared. All right, number 18, we've got an object that's going forwards and it's slowing down, and we want to know its total distance. Well, the total distance is going to be the area between the line and the x-axis, which means we're going to have to do two things here. We're going to have to do two triangles, 1/2 base times height plus the other 1/2 base times height. So we do 1/2 times 3 times 30, and the other one would be 1/2, and the base is just 2 from 3 to 5 seconds. And the height for that one, well, it's just going to be total distance, so I'll just leave that as I know it's 20 meters per second in the negative direction, but we're just looking for total distance here. So if we do that correctly, we should get 65 meters. If we want the displacement, well, what we can do is we can do 1/2 times 3 times 30, and then we could do 1/2 times the 2, and we'll make this negative 20 because it's going back the opposite way. If we do that, we should get 25 meters. Well, average speed for part C. Average speed is going to be, I'll just put this, average speed is defined as your total distance over your time, which is going to be 65 over 5, which should get us 13 meters per second. And average velocity is defined as your displacement over your time. So that would be 25 over 5, which is 5 meters per second. All right, I am 14 minutes in. I'm going to have to pause here. I believe the video will cut me off after 15, so I will have to make a part 2 to go over the rest of this worksheet. So go ahead and stop right now, review if you need to, and then you can hop on over to the other video. Thanks.